All right, guys, I'm sorry about that. The computer was just freezing, so I decided to stop the video. So we're going to try and do this last example on this second video. So if you didn't catch that, our last problem from our last example was calculating the rate, and I never got to write it down for the last video. So the rate ended up being 13 molar per minute. Okay, so here we go, our next example. We're going to consider the following data for the reaction between A and B to form C. Okay, so once again, we need to look for two trials where one of the reactants is held constant. So if we look at trials 1 and 2, the concentration of A is held constant. So we're constant here. So that means we can look at B and figure out what is the rate order with respect to B. So if we notice between trial 1 and trial 3, our concentration of our reactant goes up threefold. So what happens to our rate? Notice our rate doesn't change at all. So our rate here is constant. So my question then is that a zero order, a constant line, first order, a linear line, so it goes up the same amount, or is it an exponential where it does a square? Well, we just said it was constant, so this would be zero order, okay? So our exponent for B is going to be 0, okay? So I'm just going to put that 0 there. Now we need to find two experiments where B is held constant and A is changing. Excuse me. So if I look at that, in trials 2 and 3, B is held constant, but A is going up 3 times. Okay, so what happens to our rate? Let's see. Now this is kind of tricky. Notice the power of 10. So this is really 3, and this is really 27 when we look at the power of 10, right? So 27 divided by 3 is really 9 times. So our rate goes up 9 times when our concentration is tripled. So is this zero order, constant? No, it definitely goes up. Is it first order? Does it go up the same amount? No. 3 is not equal to 9. Does it go up as a square? 3 squared is 9, so yes. So our exponent in terms of A is going to be a square, okay? So we've now determined our order of reaction with respect to A and B. So our overall, remember the overall is the sum of our exponents. So if I take my exponent for A, which is 2, plus my exponent for B, which is 0, my overall is 2. Overall order. So this is a second order reaction overall, okay? So let's I'm going to just write our reaction. So our rate is equal to K times our concentration for A squared multiplied by our concentration of B to the 0. Now, you know that B to the 0 always simplifies to 1, and 1 times anything is anything. So I can really simplify this rate law equation by saying our rate is equal to some constant multiplied by A squared, right? So that's really all we have to do. So to find our K, I'm going to just grab this stuff from the very first reaction. So here we go on example B. So our rate law, let's see, I don't want the highlighter anymore. Our rate is going to be equal to K times A squared. Now let's isolate for K. So if I isolate for K, it's going to be rate over the concentration of A squared. So our concentration of A is 0.1, and our rate is 3 times 3 times 10 to the negative 3. So I'm going to have 3 times 10 to the negative 3, and I have molar per second, moles per liter per second. And I want to divide it by A squared, which is 0.10 molar squared. Okay, so when I do that, let's see here, 3 exponent negative 3 divided by 0.1 squared, that gives me a rate of 0.3. Okay, so, or a constant of 0.3. So my constant will be 0.3, and I have 3 sig figs, and let's look at this. So the mole, so I will have per second per molar. Okay, so hopefully my units are done right. Okay, so now I want to find my concentration of A for experiment 4. So I'm going to try and find this. So I need to find this. So I'm going to plug this in to my equation. Okay, so if I isolate my equation for A, let's isolate my equation for A. So oh, it didn't switch over yet. Come on. So A squared, right, concentration of A squared is going to be equal to R over K. Do you guys agree with that? So that means the concentration of A is going to be the square root of R divided by K. Do you guys agree with that? Okay. So when we do this, actually we have just 2 sig figs here. So my R is 9.00 times 10 to the negative 3, and it is molar per second. Okay, and I want to divide by my K, which is 0.30 second per molar, and I want to square root that. Okay, now notice that my seconds cancel out, okay, already. So I'm going to take 9 times 10 to the negative 3, and I'm going to divide it by 0.3. So that gives me, before I simplify, that gives me 0.03. So that will simplify. Now I'm going to take the square root of that. Okay, and when I take the square root of that, I get to 2 sig figs, because I really only have 2 sig figs, 0.17. And my unit, molar squared, is square root of squared is just molar, which is the unit that I want. I want molar. So my concentration of A is going to be 0.17 molar in that. Okay, so that is how we use rate law to determine order of rate law, determine rates by plugging things back in. Have a great time, and we'll talk to you later. We'll see you. Bye.